Hello, everyone. Welcome to the Ionic YouTube channel. My name is Logan Braid. I'm developer advocate here with Ionic. And today I'm joined by Dallas. Dallas, if you could introduce yourself.
Hey, Logan. I'm super excited to be here. Hey, everybody. My name is Dallas James. I am the product manager for Capacitor here at Ionic.
So, Dallas, what are we going to be talking about today?
Yeah, I'm really excited. So over the last couple of weeks, I had this idea for an application, which I think we all kind of get those. And I realized I'm probably paying too much for ChatGPT. It's great. I love it. I don't think I use it for $20 a month, but I'm a developer and I know how to use APIs. So I thought it would be really fun to take advantage of their API and build a ChatGPT clone for myself using Capacitor so that I could ideally save a little bit of money every month.
Oh, there you go. I know. Well, ChatGPT, they charge too much.
I know, right?
We're struggling developers. We have to pay the bill somehow.
Yeah, so I thought it'd be fun, Let's build a ChatGPT clone, and we could take advantage of Capacitor, and it's a good exercise to stretch your legs and just have fun building an application.
Yeah. So maybe why don't you tell us about some of the tech that you use to build this?
Yeah, absolutely. So for me, there's all sorts of tech choices that you can make. I really just kind of went with my favorite tech to use right now. So obviously built on Capacitor. Yeah, there's not really any other choice there. Am I right?
Yes.
So built on Capacitor so we could ship this to web and Android and iOS. Because yes, I have all of those devices in my house and I need all of them. Additionally, for the actual application itself, I chose to build this with Solid.js. So that's kind of my go-to framework of choice when I can get to choose. I really like it. It's very React-esque, but it has all of the little nooks and crannies figured out where React kind of will foot gun you if you're not careful. So really like Solid. So I picked that for my UI library and then built with Tailwind. I just wanted to get something that will go quick and easy. And then on top of Tailwind, I decided to pick up Daisy UI, which is a component library built on top of Tailwind, which I really, really like and highly recommend. So doing that. And then for all of the infrastructure work, I went with the most glorious and awesome Supabase. Big fan of Supabase. I've used it in several projects, and for this application, it was a perfect fit. I needed something with simple authentication. I don't necessarily need hosting, but so I needed something with simple authentication with edge functions that can run all of the code completions and kind of keep all of the tokens for OpenAI secure. And that's about it. I also take advantage of real time because it's cool to take advantage of real time, but not a hard requirement, but really like it for that.
Oh, nice. So why don't you go ahead and open up the project and we'll start diving into it. As Dallas is opening that up, if you like what you see, please be sure to like and subscribe to the channel. We're going to be having all sorts of different content relating to ChatGPT, interesting projects, how to do new and different things with Capacitor. We really appreciate it. And of course, be sure to check out the Ionic blog. The Ionic blog has a ton of great information like tutorials, product updates, announcements, and more. For more information, be sure to check out the Developers tab on ionic.io to view our docs and join our communities. We have an active community of Ionic developer experts on our forum and Discord that can help you through your Ionic journey and build the applications that you want to build. Our forum, docs, and Discord are great resources for any questions, comments, and feedback that you may have to supercharge your applications as you're building them. Links will be posted down below. Open. I think the audience can see Visual Studio's open. Why don't you tell us about your project and your code, and let's walk through it.
All right, yeah, let's jump in and take a look here. So we're in a VS Code workspace, and we're in this workspace because our application actually has two different parts. The main part is our project root, and that's all of our Capacitor application, everything that's going to run that application, all of our Supabase infrastructure, with the exception of our edge functions. So Supabase edge functions are built on top of Dino as opposed to Node, and so they have a slightly different tool set that you use. So VS Code has this nice little workspace so we can kind of separate those out as we work through them. So let's just kind of talk through the project about what this was. So the goals of this project really are pretty straightforward, right? I need some sort of user interface that replicates something pretty close to the ChatGPT interface, and I want to be able to have it in a mobile app. So that's basically the requirements here. So in terms of our pages that we're going to look at, we really only have 2 pages. We have our home page, which this is more of like an unauthenticated page where if you're not logged into the application, you'll be here. And then we have our chat page. So once you're logged in, here's the page we use to actually sit down and chat. So we can kind of talk about each of those different pages and what they are. So if we start here at the home page, we're using Supabase authentication, which is great because it has all of the different pieces kind of built in for us. So we don't need to do a whole lot of work there. What we're going to do, if we scroll down here, we can see our UI. We have our title. This is the self-titled Starfleet AI, which is kind of fun. So I'm not actually a Star Trek person. I didn't realize that Starfleet was from Star Trek, and everyone I've showed this to has been like, whoa, yeah, Star Trek, that's so cool. And I'm like, oh yeah, look at that. I didn't. Yeah, that was absolutely my intention.
So the entire Starfleet reference was a complete accident?
Yeah. So it's actually how I name all of my home Internet of Things. So my entire network is my Starfleet network, and all of the different, nodes on my network are different entities on that. So like my main computer that actually runs everything is called Star Commander, which I thought was just kind of fun. And this is now the AI tool that's going to run it all. So total accident, but it worked out. Worked out real fun. So this is our Starfleet AI application, and we just have a simple form here with our email and our password that we're going to use to log in. And that's about it. So we can see when we submit this form, all we're going to quickly do is jump up here to this on form submit. We're going to try our login. We make sure we have our email and password. If you're familiar with Solid.js, you'll recognize signals here, which are basically the better version of use state. Don't at me. We have our email and password that we're pulling here. We're making sure we actually have valid values for those before we try to submit, and then we'll submit those to Supabase. And if we get an error, we'll pop up an error for the user. It'll probably say, you did something wrong, invalid credentials. Otherwise, if there's no error, we're successful, and we'll go ahead and navigate into our chat page. Pretty simple and straightforward as that. So once we get into our chat page, we kind of get into a little bit more of the complexities of the application. So there's a couple of different moving parts. And when we talk about how this application is designed, I think one of the best places to start is to kind of look at the data structure inside of Supabase. So we have our migration files for Supabase, and this is how we define our database. And this is really what we're going to drive all of the architecture of our pages and how everything kind of interconnects together. So everything is built on top of this single chat object, this chat table, right? It has an ID. It's linked to the user who owns it, so we can make sure only that user has access to it. We give each table, each chat a name so that we can, make that visually interesting for the user. They can recognize what chat they're in. We're going to enable row-level security. So if you've worked with Supabase and Postgres, you'll know that row-level security is a way to authenticate your users to ensure that they can only access the data they're supposed to. We have a couple of different rules here that we are implementing. So we want to make sure that only the owning user can read their own chats, right? If you're not the user on that table, you can't actually read the chat. Same thing. You can only insert chats for yourself. We don't want someone inserting a chat into someone else's thing. Definitely don't want that. And even more so, we don't want anyone deleting anyone else's chats.
Yeah, so, we want to make sure that this is completely secure, right?
Yes. Secured and locked down. And you also notice there's no way to, we haven't enabled any rules for updating. So with row level security, right, it's deny by default, and anything we want to allow, we have to explicitly allow. So once you've created this, there's no changing it. There's no going back. You're stuck. The last part here is we made a helper function that we'll use later, which is a way to identify if this user is part of this chat. And so this is just a database function that returns a Boolean true false. And we're basically just seeing, does the user have access to this chat? So we're looking for chat where the chat ID is based off what we pass in and that the user ID matches. If we get a record back, great, it exists. The user is in the chat. Otherwise not, we get false, the user's not in the chat. And we'll use that later when we're checking other rules. So that's kind of our top level chat structure, right? So this is what forms the backbone of this application, because we have different chats and everything is going to be related to an individual chat. So if we scroll down, we have our chat messages. So this is the next part of this. So whenever a user or the AI sends a message, we want to be able to save that in our database so it doesn't just disappear on us. So we create our chat message. Again, we have our ID, we link it to our chat, we're saving the message text and when it was created. We're also tracking who created this. So you'll notice this is by default created by humans. And this is a author type. This is an enum generated in our database just up here a little bit. If we scroll up to the top, author type can be human or AI. Those are your two choices. There are no in-betweens. And then again, we're also going to enable row-level security. We're also going to add this table to Supabase real-time. So the benefit of doing this, we'll kind of see later, is if we have multiple instances of this application open, say I've got it open on my desktop and I also have it open on my phone, the messages will stay in sync between those two different instances. And so when I send a message on web, it'll just automatically show up on my phone, which is great. So we're going to add that to the real-time. And then we're just going to tell Supabase we want the entire identity whenever that message is inserted or updated. And then again, we're going to write our policies here, right? So for chat messages, we want to make sure that the user who owns the message can read that. And the way we understand who owns that, because there's no user ID on this, we could put a user ID on this message, but then how do we, when the AI responds, does the user doesn't really own that message? That wasn't their thing. So that's where we get back to that user and chat function that we created, right? We make sure that anyone who is in this chat, which is just the user who created the chat, will have the ability to read all of the messages in that chat. And then same thing for insert. We make sure that the user is in the chat. And then we have one additional rule. We also say that a user can only add messages that are created by humans. So you can't jump in and say, oh, I'm going to type up a message and I'm going to send it as an AI because I am the most advanced AI there is. That's not possible either. So
nope.
This is, you have to be human, right? So that is a restriction we've put on inserting documents into this database, is you can only insert if the created by value is human. Then we create one additional little helper function here. This will just update the updated at time on the chat document whenever we add a new message to a corresponding chat. So that way we can go through and we can sort the chats by when they were last, when the most recent message came in. So we do that anytime we insert a message on chat message, we will execute this function here to go update that time on our chat. So that's our structure, right? That's really all that we need. So we have two tables, we have our chat and our chat messages. And with that, we're kind of ready to dive in and look at the actual application code a bit more.
Yeah, let's jump into it. Let's see what it looks like.
So if we look at our chat, the actual container itself is pretty straightforward. We have a quick check to make sure that we have a user. We also have this effect up here that if there is no user, it's going to throw an error that you have to be logged in, and it's going to kick you back to that home page. Right? We don't want, you have to be a user. Otherwise, you can't have any chats. You're not welcome here without being a user. Otherwise, our interface is pretty simple and straightforward. We have our chat header. We have our sidebar wrappers. This is what's going to give us our sidebar. We have our message space. We have our chat input bar. And that's about it, right? That's the entirety of our interface there. So let's take a look at the code. I think this would be a good time. We'll drop out of Zen mode and we'll see what the end result we are looking to get out of this is going to look like. Okay, so we have our chat interface here, right? So we can kind of see we have our history off to the side of all of our different chats we've been having with the AI, and we have our message box down here we can type into. It's currently disabled because we're not actually looking at a chat. We've got our title up here. So what this will look like is if we want to create a chat, we'll have this option and we'll say, this is Capacitor show. We're going to use GPT-4 for this. It's going to go ahead and create our chat. And now we can start talking to the AI. We can say, hello, AI. My name is Dallas, and I work for Ionic. Send that off. You can see we've got that nice little streaming back action. Look at that. And it all knows who I am. It wants to know how it can assist me. So we can, maybe ask another message and be like, how do I Center a div on a page. The most difficult of all questions.
Yes.
Right. And we get our nice little response back. And so it's going to, come in and do this. And there's a lot of functionality going on here that we'll kind of dive into throughout the remainder of this video here. One of the cool things about this, though, is this bot has memory, right? So if you've ever worked with the API, right, when you make a request, you'll get an answer back. If you make another request, there's no memory involved, right? But if we come back and we say, what was my name? And we ask it, it's going to come back and say, your name was Dallas. That's great. It remembers who I am. So this even has memory available to it as well. So it'll be able to, remember who I am, remember details of the conversation we've had. And so you'll be able to kind of get into that deep introspective conversations you'd have with ChatGPT, which is how I like to use ChatGPT. I like to, have these ongoing conversations and kind of use it to build out ideas. So this is what we're building out. So we can kind of see that structure in our code here. Look, there's my environment variables. Let's see. Yeah, so if we look at our chat. So if we come back to our code, we'll see that this is really the structure we have here in our code, right? We have our header, which displays our chat name. We have our sidebar, which contains all of our history. We have the message space, which is going to render out all of the messages. The input bar where we can type everything in. And that really is the entirety of our application. So if we look into our components folder, we can see there's a handful of components that build all of this up. We can kind of start from the smaller pieces, and then we'll talk about how they all work together at the end. So the different messages, if we look at those, are really straightforward, right? We have our AI message, which is going to take a structured document from our Supabase table that we created, our chat message, right? If we look at this message and everything that's entailed on it, right? We have our chat ID, the message text, who created it. And then we have all of this laid out. And you can see this is very Tailwind, right? It's built on Tailwind. So a lot of Tailwind classes you're probably familiar with, as well as a lot of the styling that's brought in from Daisy UI, which is great that all of this is, super simple to build out. There's not a lot of custom CSS in this application at all. So we just have our little chat bubble and we have our message text. We'd see that if we have an AI message that hasn't responded yet, we'll have an empty text and it will give us our nice little loading dots. So we can get that visual feedback that it's coming in. Our human message is a little bit simpler. We never have a human message without text. And so we can just display the text, and otherwise it's about the exact same. So those are our messages. We have our message space. So this is what contains all of our messages, which again is very simple. We just have our single container that, sets up all of the layouts here. And then we just loop through all of our messages that we have as part of this chat. And then we look, was this created by AI? If so, render out an AI message. If it was not, we'll render out a human message. And that's the basics of it. The only other complex part of this is that eventually, once we get enough conversation going on, so we pull this back over, and maybe we ask about thunderstorms, what is a thunderstorm? Oh, I can't type. Right? You'll notice that as this message will start to get up above the screen here, and in fact, we can speed this up by zooming in. This is automatically scrolling down for us as each new line comes in, right? We don't want to kind of lose all of our text below the fold as the bot is talking. We want to make sure that we see that as it comes in. So this code here handles that for us, where we come in and we say, okay, every time our messages signal changes. So this create effect is essentially the solid JS version of use effect with a little bit better ergonomics. And we say, based off of when messages changes, we want to scroll to the bottom. And if we look at our scroll to bottom function, all this is really doing is a whole bunch of logic about, should we actually scroll to the bottom? We want to make sure that the user hasn't scrolled all the way up to the top. Because one of the very worst things that can happen is you're reading something way up high and you get forced to the bottom of the page because a new message came in. It's super annoying. So we do a bunch of logic to just kind of check that. This is basic. I'm sure you could refine this and make it a lot more complex. But at the end of the day, we decide, should we scroll or not? And if so, we scroll our container to the bottom of the page.
That's a nice little slice of life thing right there. That's really nice.
Right. Yeah. Yeah. So you just kind of keep yourself at the bottom. If you've ever had to build a chat application, this is one of those things that can be really annoying if you don't get it right, and it'll drive your users crazy, because they're constantly not getting pulled down right, or they get lost in the messages, or something appears below it and you just don't know it was there. Yeah. So lots, this one little piece of code right here goes a long ways to user happiness. So yeah, that's our message space. This is everything that's rendering out all of our messages in the middle. If we look at our input bar, so this is specifically that text area at the bottom that we're using to send messages. We can see that when we send our message, we'll kind of look at this first because we do a couple of checks. We make sure we have a chat. We make sure that there's nothing currently in flight. If we're waiting for a response from the AI, we don't want to be sending multiple messages repeatedly or accidentally hit the send button 2 or 3 times. We'll do, again, just a quick check and make sure we have our chat, that there's a valid ID, and then we're going to structure a new message with all of the appropriate values. We're going to optimistically add this to the UI early. So something that if you're developing with a database, right, there's a lot of latency that can happen between the time you hit enter and it goes to the database, it saves it, it comes back, it says, okay, we're done. And this application, we've chosen to be very optimistic that all of our database writes will be successful, or at least the majority of them will be. And so I've gone through and added the message to the UI ahead of actually saving this so that we're not waiting on that latency, so that it's a faster perceived performance for the end user. And then what we've done is after we insert this from Supabase, we actually grab our error document that will come back. And if there is an error, we'll display the error to the user, and then we'll go back and remove that again from the UI. Now, you might have some more complex behaviors, if you were building this out for anyone that wasn't myself, right? This is just for me. So it's okay if it just rips that message out of the UI. But, maybe you want to mark it as failed and give the option to resend and try again or something like that. But in this case, we've optimistically added it so that it will be there, hopefully. And then assuming all goes well, great. We had an instant response time instead of, the 200 to 300 to, even 2 or 3 seconds, 200 to 300 milliseconds or 2 to 3 seconds wait time from that round trip to actually go save the message to the database. Once that's done, if it was successful, we're going to clear out our input field. Doesn't need to be there anymore. And then we're going to send the user's message off for response. And basically what that means is we're going to send it off to the AI to go get a response. And we'll kind of look at how that works later. Other than that, if we look at the UI, again, very simple UI here, right? We have our container, we have our form with our text area inside of it, and our send button. That's about the effects of it. We have a couple of helper functions. Typically when you hit enter, you want to send a message. So this handles hitting enter, it'll send it. Unless you're holding the shift key, then you get a new line, right? So that's also some pretty common functionality in terms of your chat applications. So just kind of replicating that a little bit. So that's the majority of the chat functionality, right? Those 2 components. If we jump over into the sidebar, this one's a little bit more complex, but it's only complex for one reason, and that's the mobile behaviors. So we'll kind of get to that in a second. The chat sidebar wrapper here, right? You see there's a whole bunch of signals, a whole bunch of information. Realistically, all that we need here is our chat, so we know what's open. And then if we jump back down to the UI, again, this is more complex, but if you really look at it, a lot of this is, here's the toggle for the drawer. So by default, if we come back over here, on large screens, right, this chat history bar is static. It'll stay there. But if we pop open our dev tools and we scroll this down, that will collapse in on itself and become a drawer. It'll slide over the content, right? So that'll feel a little bit more mobile, because we do plan to deploy this both to web as well as to a mobile device. So we can see if we even shrink this down all the way to an iPhone 12, right? We get this nice little good looking drawer here that we can use to cycle through all of our different memory or our different chats. So a lot of what you're seeing here is just that UI for that. And if you're using something like Tailwind and Daisy UI, all of this is done for you. It's great.
That makes it a lot easier, right? Like you don't have to custom develop all of this user interface stuff.
Yeah, most of this is copy paste for the most part, right? I think the only thing I have is I forced the drawer open on large screens. And that's probably about the extent of my customizations to this, which is pretty great. All of this otherwise comes from Daisy UI. So we look at this. This is just our toggle, right? This is our main container where the rest of our application will live. We have our drawer. If we could look here, this is our create new chat button. And we loop through all of our available chats and create, elements for each of those and allow the user to click on those. And then we have our giant spacer, and then we have a logout button at the bottom. And that's the entirety of it. So while it's a little bit more complex, at the end of the day, it's actually pretty darn straightforward. So if we look at what the different options are here that this does, right? If we select a chat, you'll see we're actually storing the chat in our URL parameters. So that's incredibly helpful if you wanted to save state, right? So in terms of what chat you're in, right, this up here, we have our ID, right? The URL is a great place to save state like this, and that's including on an application, right? So that if you ever were to add deep links to your application, you could then potentially share chats in the future, right, with someone, and you could link directly to those chats. Or for myself personally, maybe I want to bookmark a chat and I want to bookmark one specific one that I always want to jump to. So putting that ID in the URL bar is a great use of that URL for managing state of your application. So anytime we select one, we update that ID in the URL, and then we go ahead and tell our application to open the chat. And you'll see we actually have all of these chats because when we load this page, so when we load the page, we're actually grabbing our chat list. So this use chat list is a resource. So this is kind of getting into a little bit more of the nitty gritty of Solid.js. But a resource is just a way to fetch data from somewhere and bring it back. And then it gives way, opportunities to refetch that data if you needed to. So you'll see we've just created this resource. We grabbed our current user, and we're just asking Supabase for all of the chats that belong to the user and sorting them by whichever was updated most recently, and then returning that back to the user. So nothing too complicated. Suffice to say, this use chat list is basically a way to go grab the chat list, and then it also provides us this method to refetch that chat list if we ever want to refresh that data for some reason. So we have all of our chats, and then when we actually go to select a chat, right, we're just passing in, again, that reference, that entire structure of our table, right, which has our chat model, our name, the ID of the chat, who owns it, all of those important fields. And then we go ahead and close the drawer so that we're done. And that's about the extent of this. Now, there is all of this code here in the middle. If you're interested at it, I definitely recommend checking out the GitHub for this.
Yeah, where can our viewers see that?
Yeah, so this all lives on my personal GitHub, but this is all open source, right? It's one of the big motivations here at Ionic is we like to create open source things. So if you jump over into my GitHub, and you can find me on the Ionic team, it's github/DallasTJames, or you can always ping me on Discord, and I will shoot you all of the information you need. We can talk about it. I like to hang out on Discord.
Oh, there you go.
Plug Discord there. Come hang out with me on Discord. It's great. But yeah, so this all exists on my GitHub. I think did I even have that open somewhere? Hey, look at that. I do.
Hey, there we go.
So yeah, so there's the URL if you want to come look at that, right? It's github.com/DallasTJames/Starfleet-AI. So all of this is there. It even talks about, if you want to build up the application. I'll probably improve the README a little bit better, but this is all here, right? Everything that we're looking through is all hosted there on GitHub and is open for anyone who wants to look at it. To talk just a little bit about this, when we have our app, when we're on mobile, if you've ever used side menus on mobile, you always swipe them out, right? At least I do. I don't know if you're like that, Logan, but I just I can swipe out the menu, you swipe it closed. Yep. And Daisy UI, well, it's a fantastic component library. It is a CSS library, which means there's no JavaScript at all in there, which is really cool because it means it's compatible with whatever framework you want to use. But that also means it's missing some of these critical behaviors that you would expect out of an application, like being able to swipe open this bar. So all we've done here is added some event listeners for touch start, touch move, and touch end, so that when we are on mobile, I'll pull this back over. Can you zoom this in? No, it's not going to zoom in. It'd be a little small. Sorry. But if you touch and drag, you get this nice little motion as it pulls it out.
The amazing thing is with the power of editing, we will be able to zoom in.
There you go. Yeah, it'll be zoomed in post.
Yes.
Yeah, so you can touch and drag, and you can kind of play with this, and it'll move around, and you can flick it open, and then you can flick it closed when it's open. So
there you go.
Yeah, so it's just a little bit of code there, 100 lines or so, just to kind of get that native feel for when we're on mobile. So that's the majority of the logic in here, is doing all of the fun math of which direction is the user swiping, and should we open the drawer based off of how wide and how far they've gone. And so you can kind of get into the nitty gritty. It's fairly straightforward overall. Yeah, that's our sidebar. So at this point, we've kind of talked through all of the different pieces. So the last little piece to talk about is, how do we put this all together, right? We've talked about, here's how we have our chats, then we open our chat, and then we display messages, but where do the messages come from? How do we know what messages to load? Yeah. Well, again, if you're familiar with React or anything similar, right? We have our context. So we maintain this chat context for our application. And essentially what this is a couple of global signals that just maintain our chat, whatever one is currently open, or null if it's none. And it also maintains all of our messages, or an empty array if there's none. So if we look down at our chat context, we've kind of built this out using that like hook style context. So we have our use chat context we can use anywhere. We're grabbing our reference to Supabase so we can use this. And then we just return an object with a bunch of tools that we can use everywhere. So our chat object here is our current chat. So you'll see this is the signal. If we look up here, right? Our current chat is the signal with our chat. We have our messages, which again is the signal with our messages. So we're providing these signals to all of the different components that need to use them so that Solid can optimize that rendering behavior for us. We also expose a method for adding a message. So we grab our message type. We expect an instance of our database table. We do a quick check to see if there's an existing index. So if the message already exists, that's great. We'll just update it with whatever data came back. And I've left a little comment here, right? This is useful for if our streaming breaks down. So if, how we stream those messages back to the UI, if that breaks down, the database will send us a copy when it's all done. And we'll go in and we can just update it so that it will fill in all of the details, so we don't actually lose any data. And then we'll go ahead and return that. If we don't find it, we'll just append it to the end of the message list. We have our send for response. So this is probably the most complex part of the application itself, where we're going to take this message, and you'll recall we use this as part of our input bar, right? At the very end, after we've saved our human message, we call this send for response, right? So we look at this, we're pulling this out of our chat context. So send for response, we're going to go ahead and we're going to preemptively create an AI response, right? We're going to say we're expecting one to show up, and we're going to set it to empty message because it hasn't responded yet. And we're going to go ahead and plop that right in the AI, or right in the UI, right? Again, we're being optimistic so that we're getting very fast, snappy results from our UI. We're not waiting for a database. We're not waiting for an API. We want the user interface to be responsive. So we're going to go ahead and plop that AI response into our UI. And you'll remember with our AI message, if that text is empty, we're going to show that loading dots. So that's where you get that loading indicator saying that, we're waiting for a response to our, we're waiting for that response because we've added it to the UI, but we don't have a response back, right? So if we look at this again, we'll scroll down and be like, give me a story. You'll see we get that loading indicator right there, right? That's all preemptive because we've added that before we've made any calls to the database or anything like that. Like it's even telling us a story about the planet Starfleet.
It's writing you an entire script for Star Trek.
That's what it looks like, huh? Dazzling purple lightning, a curious scientist named Kara. It's pretty fun. We'll have to come back.
It is going. It is.
Yeah.
It has a lot to say.
It's going to use all of my OpenAI budget there. So yeah, so that's our optimistic behavior, right? Once that's done, we're going to grab our Supabase session, and then we're going to just make in a call here. Right? We're going to call our Supabase URL, our functions, and our chat function. So we have an edge function. We haven't talked about this yet, other than to say this is part of our workspace. So this we'll jump over to there. We have a chat function that we're going to call. And essentially, the goal of this chat function is to take in the message, and it's to talk to OpenAI. And the reason we do all of that as part of a Supabase function, as opposed to doing it here, is because our OpenAI key is it's a secret key, right? You should be careful with what you do with that. You shouldn't put that into a public context. So anything in our application here is all public context. So if we look at our env file, I'll make sure to click the right one. Right, we have our Supabase URL, right? This is an actual hosted instance, right? You could actually go this, you could plug these information in, and you could access my Supabase instance. These are all part of the repository because it's totally okay to have these. These are public values, right? You can share these around. However, your OpenAI key that you will use as part of this chat function is not something that you can share around, right? That's something you need to keep because that's what gives access to your OpenAI account. So we're going to use an edge function here so we can keep that secure on the back end. So we have our Supabase URL. We're going to post to our functions, to our chat function that we will create. We'll talk about that in a bit. We're going to pass in the message that the user is typed out. We're going to send this message ID, right? And you'll see this is the ID of the AI response message. And so that's how it will know to actually send back information for this message that we optimistically put into our UI. We're going to send up our headers, including our authorization, right? We want to make sure that our user is authorized with the access token. And then we're going to listen for an on message, and we're going to handle stream message. So you'll see this is actually fetch event source instead of fetch. This is what allows that streaming behavior. This is just a third-party library. So if we pop into our package JSON, right, fetch event source, this was a package built by Microsoft. This is what LangChain uses in a lot of their documentation for doing this. So that's where I grabbed that from. And that's all this is doing is allowing that streaming back to the UI, right? So as we get each individual piece, we grab our message, and then you'll see we're just going to handle our stream message. We're going to say, the data that comes back is going to get attached to this. This handle stream message is just up here above. And you'll see we're going to, so this is a fun fact. If you've ever used the official ChatGPT app, right, whenever the AI types, it like vibrates your phone a little bit. So one of the fun things we've done with Capacitor, and we'll talk about this when we come back to the Capacitor side of things, is we actually replicate that and get that same haptic feedback, it just makes it more fun to use. So for every little piece of information that comes back from the API, we're going to just hit that haptic engine a little bit. And then we're going to go into our set messages, and we're going to go ahead and update your message. There is one little exception here. So anytime we get blank characters, this is my experience with the API. I'm sure there's better ways to do this and actual handlings for this. But any blank characters or blank message is essentially a new line. So this will go through, it'll take our message. It's going to append this to the previous, whatever was existing there before. And it's going to update our UI with it. So that's what gives us that nice streaming behavior, so where it looks like, all of the text is just coming in, as the AI types it back out for you. And that's our chat context. You've got a couple other helper methods to remove a message from the UI, right? We talked about we're optimistic here. So if something goes wrong, we can use this to remove the message. And we also have a way to reset messages in case we ever need to clear them out, or we open a new chat that has new messages. We'll reset all of the messages that are in there. And one other helper for when we want to open a new chat that will set the current chat and clear out the current messages. So that's the entirety of our context, and that really is the entirety of our application. So we put all of those things together, and that gives us this lovely experience of our Capacitor application, right? We have our different chats here. You can see we can load those in. We can type in and tell me another joke, please. We get this nice little streamed back response, right? And we get this nice little joke about a bicycle falling over.
Because it was too tired. Oh, and it's even telling dad jokes too.
It's
All
telling
right.
dad jokes.
It's
That's
telling
part of
dad
the
jokes.
that's part of the prompt. It's requirement.
So now
yeah.
now that we've kind of seen like the web side of the application, how do we get this on mobile? What does the mobile section look like for this?
Yeah. So to bring this to mobile, so this is what I love about Capacitor and why I think it's one of the best ways to build mobile apps. We've built this really great web application. We've built it with mobile responsiveness in mind. So to bring this to Capacitor looks incredibly simple. So I'm going to go ahead and close this out. There's like 2 or 3 steps realistically that we need to do. First, we're going to come to our package.json. We're going to install the Capacitor CLI. So if we open this up here, we'll go ahead and clear that out. The root of our project. So if we're going to do this, if we were doing this fresh, right, we're going to go ahead. I use pnpm. I have an alias for pn, but pnpm, right? And we're going to add Capacitor CLI as a dev dependency. Right, we've already done that. So that's the very first thing we got to do. Once we've done that, then we can do npx or pnpm cap init. All right. And when you do cap init, it's going to create this capacitor config file. It'll ask you a couple of questions. What do you want to name your application? What do you want the bundle identifier to be? Right. It's a couple of questions, and that's what generates this file here. And then the last real step you have to do is actually install Capacitor. So there are 3 core parts that you need. You need Capacitor core, and then the platforms that you want. So in this case, I'm deploying to both Android and iOS, and then any plugins. So in my case, I'm only using one. All right, I want to access the Haptic engine. So now we can go pnpm add at Capacitor, and then we're going to say we want core, Android, iOS, and Haptics. Okay. We're going to add all 4 of those. So we would run that command, and it would install all of those for us. At that point, now we can tell Capacitor, generate my projects for me. So we're going to do pnpm cap add iOS. It's going to add our iOS project, and cap add Android. So all of these Capacitor CLI commands are, they're in the documentation on the Capacitor.js website. They're all meant to be run locally like this, right? So Capacitor CLI is not a global CLI that you might install like some other project types would be. It's just local to your project, and that's why we run them like this. Once we have that done, we're good to go. So I made one change.
So that's it? That's all it takes to get it to mobile?
That's it. That's on mobile. I made one change here to where every time we do a build, it's just going to copy the build assets over into Capacitor. So if we do npm run build, and so you'll see this will run through. It'll just take super quick, right? So our build took 2 seconds. Copying this over into iOS and web and Android took, milliseconds. And then we can use this pnpm cap open to actually open a project. So we'll do iOS for the example. So it's going to open our Xcode workspace. So we've got Xcode open now. This, again, I've been already testing on this a little bit, right? So you can see that I have my bundle identifier here. I already have my signing team, and all of my signing certificates have been set up. If this is your first time doing this, you'd have to set those up yourself. But it really is just like click a button. And we're going to go ahead and build this. I would do it to my iPhone, but then no one would be able to see it. And so we'll just pull up our iPhone 14 Pro, and we'll go ahead and spin this up to the emulator here. Cool. So we've, you hit that play button, and we get our simulator popped open over here with our application running. So we can go ahead. Yes, I know how to type on a keyboard. Thank you. And so let's go ahead and sign in on this. I should sign into this one. And we get signed in, and you'll see we have our select chat. Again, we can't send messages because we haven't picked one. We can open up our side menu here. We can see all of our messages. We can see our joke was the most recent one. We've got our joke here. Oh, Hey, look, I was trying to figure out how to zoom in Xcode last time in between cuts.
You've been caught.
Oh no. Ignore that. Hey, look, here's our story again. Nothing too crazy happened there.
I am 100% keeping that in the cut.
Yeah, it'll be great. So, okay, so then we'll pull these up side by side because we can kind of see them working together. So we have our application, we have our web version of it. If we look, there it is again. So we've got our capacitor show, we've got both of our texts, and if we pop over into mobile, we can grab our keyboard here, and we can, just hello world this. We'll send that. You can see our hello world popped up automatically over here. You also see we don't get the streaming in the web version, but when it completes, we get that new version. And that's because, the web version didn't request the stream. So if we come back, we can, tell me another story, so that it gives us a bunch of text. But you'll see we get that nice, streaming behavior on our application. If you're running this on a physical device that you can actually feel, you get that nice haptic feedback. Man, I wish I had a good way to show that on stream, because it would be so good. It's so good. You have to go clone this, build it from source, and just so you can experience it, because it's that good.
One day in the future, we'll be able to capture this.
One
the
day.
haptics on this. One day.
It'll be great. So we finished our story, and we see that was replicated over here. And, that definitely goes both ways too.
That's amazing. So this application is like truly cross-platform then. Like it basically, not only can you like deploy it and have it on mobile, but then like it actually will show up with all of your chats across whatever device you're looking at it through.
Yes. Yep. It keeps it all in sync. We've got our nice little slidey menu, right? I'm pretty proud of that behavior. I think that's pretty, it's pretty great. This is absolutely cross-platform. And I mean, it took us 10, 15 minutes. And we cut some things out as well of me trying to figure out how to zoom in Xcode. And it still only took 10, 15 minutes. That's legitimately how long it takes to just take our web application that was mobile friendly, right? We went through the time to make sure it styles well for mobile, and it just drops right into our application.
It just does it.
And it just does it, right? And then you get to go in and you do the fun things where, if we move that out of the way, where we actually do things that are capacitor specific, right? So we talked about it for just a moment, but if we jump over into the components into our context, right? Our haptics, right? So you'll see we imported our haptics from the Haptics plugin. And we just say, do a little impact, right? Which is just that little bit of vibration there. And we could pick a style. I went with medium. That felt like pretty good size. There's a couple others, right? Where there's light, medium, and heavy. Heavy felt like, your phone is getting in a fight. So I just a little bit too much. So I went with medium, and that felt really good. And this is great, right? Because this haptic engine will also work on web, which is great. So that if you have a mobile phone and it does support haptics on web, you'll also get that haptic feedback on web, which is great. You could gate this so that if you only wanted to run it on certain places, you could, right? The Capacitor has a couple of helper functions for that. You can wrap this. But this is great, right? We can leave this in and it doesn't impact our web at all, right? We've been running this in the web browser. And that's great, right? So it took us 15 to 20 minutes, we'll say, right, to actually add Capacitor, run all the NPM installs, do all of that different parts of it, add the iOS and Android projects. And at this point, we're ready to ship this to the iOS and Android stores, right? So all of that is really great. And that's really what it comes down to kind of shipping this as a Capacitor application. Any questions, Logan, before we we still haven't talked about how we're doing the ChatGPT part, which I think could be kind of fun to dive into if we got some time, but...
No, I mean, let's do it. Let's jump into the ChatGPT stuff. So I would love to learn about the ChatGPT items and how we're actually like how you're integrating with it and how like it's connecting to your application.
Yeah. So let's talk about how it talks with ChatGPT. So everything up to this point has been inside of our project root. This is all of our web application. We talked about, adding this to Capacitor and how that all works. So if we jump into the other part of this workspace, so this is our Supabase functions. This is our edge function. We have one function that is chat, and it has an index file. So the way the chat function works here, we'll move some of this interface out of the way. So the way the chat function works is this method will get bundled up by Supabase, and it will get thrown into the cloud, and it will run on their edge servers anytime you try to connect to it. So we're using this serve function, which is from Dino, right? And this will serve this edge function. This is what will make it accessible over HTTPS. And we're just going to kind of dive through from there. We're also relying on LangChain. We can ignore all the red squigglies. That's just VS Code having mental issues. All of this does work, and it is all installed. So we have this method. So anytime we make an HTTP request to our chat endpoint, it's going to execute this with all of our request details. If you're serving this from web, if you're dealing with a browser, which we are both in Capacitor and on our web, right? Both of those are running in a web browser. You have cores to deal with. And so that includes options requests where you have to reply with specific cores headers, right? You can look at this. This is super basic. Our cores headers are just setting our origin and headers that are allowed to be sent to this. And we're just taking the most lenient approach possible and saying, yes, anyone can talk to this endpoint. You could restrict this to a certain, domain or set of domains if that's what you wanted to do. But for our case, we're okay with anyone invoking this method. Once we've done that, we are pulling all of our parameters that we've sent up from our JSON. So you'll remember we sent up our user input, the message ID of the AI message to be created, and the chat with which this is all corresponding. If any of those are missing, we're just going to quickly throw a bad request and be like, hey, you're missing something. Send us all the right data. And then we're going to create two different Supabase clients, right? We have our Supabase client, and we also have our Supabase admin client. The reason for these two different types, this one will be tied to the current user, right? So whomever is actually actively logged in is going to utilize this, right? And that way, all of the row-level security policies we added at the beginning are put into effect. The admin client, however, uses the service role as part of its access, and so it can bypass all of the row-level security. And we're okay to do this we're on the server side, right? We control all of the data that's going on right now. So we can safely use this to bypass specific RLS policies. And we'll talk about those at the end of which ones we're bypassing and why. So we're going to grab our user Supabase instance. We're going to make sure that there is an actual user, and we don't want any non-logged in user to be, trying to talk to our function and using our API keys. That we want to be in control of that. So if there's no user, we throw an unauthorized error back to the user. The next check we're going to do is we're going to, again, with our user Supabase client, we're going to try to grab the chat. And we do this with our user one because we wrote that RLS rule a while ago about how only users who are in the chat can actually access that data. So if the user is not related to this chat in any way, this will come back empty, and it will throw this chat error and say, hey, there was no chats. There's nothing there. Whereas if it is the actual user, the RLS policy will enable the user to select that, and we will get the chat data back from Supabase. If we don't, we just throw a 404 not found. The chat they're looking for doesn't exist. Next, we're going to grab our model name. So we had that selection, right, of ChatGPT 3.5 or 4. We store that on our chat as the chat model value here. And so we're going to select that in case, in the off chance that for some reason chat model is invalid because of one reason or another, we're going to fall back and use 3.5. And then we do have code here so that this will use event streaming, which is what we've been using. If we don't support streaming, this function will also do the chunk, right? It will wait for the entire response back from ChatGPT and then send one single response back to the client. Then we get into the fun part, right? Now we get to talk about ChatGPT and how that works. So one of the more complex parts of this is memory. How does ChatGPT remember what you're doing? And we're implementing that in 3 distinct ways. The first one is we want, for immediate context, we want it to know what the most recent messages were. This is how it knows, what was the very last thing I asked, so that it understands what is the back and forth going on right now. Then we also want it to know what is the summary of the conversation, right? What has been the flow of this conversation over time? How has that gone? This gives our GPT instance this long-term context. And then lastly, we have a vector store for in-depth knowledge, right? So if we want it to remember specific details like my name, right? A summary probably isn't going to contain that. Maybe for 1 or 2 messages it will, but after a while, the summary will, enough conversation has happened to where it will condense that, and it'll just say, the chat, the AI and human introduce themselves or something like that. So the vector store is for actually storing very specific in-depth knowledge about the entirety of the conversation. So those are the 3 different memories we're going to configure. So the first one, for most recent context, is we grab our chat messages and we're just going to grab a certain number, right? In this case, we're doing 2. That's just kind of what I played with. But you could do more, you could do less. You need to be careful with how much you do, because if we kind of take a peek back here at our previous message, right? If we do our 2 most recent messages, it might give you thank you and this whole giant block of text. All right. That is a lot to send back to ChatGPT as context. And if you're also sending, 3, 4, 5, we hit 6, there's another giant wall of text, right? So we kind of want to be careful about how much immediate context we're providing, so that we're not spending all of our tokens, right? You can only type in so much to the prompts. We don't want to spend all of that on our history. So we're just going to do a little bit. We're just doing 2. So that seemed to work for me as that very immediate context. We also want to make sure that we're not grabbing like the AI's message or the message that we are currently writing, because we already have that information. We'll throw an error in case, something goes wrong there. That's an internal server error. There's nothing the user can do about that. The buffer memory is how LangChain operates to manage recent memory like this. So we're just creating, assigning this to a recent messages key. We have our chat history. Again, chat message history is provided by LangChain, and you just provide the messages, and it has these helper AI messages or human messages. And those are just there to help LangChain better understand the context around each individual message. Once we have those, we're going to jump to our vector store. So we're going to kind of skip over our memory summary or our chat summary for the moment. Our vector store, so this is our in-depth information. So Supabase vector store, again, this is provided by LangChain and Supabase together. We're using OpenAI embeddings, and if you haven't gotten into this, we're not going to dive into what embeddings are because it's complex math. I don't really get it. I just know they exist.
You just need to know that it's there.
Yes, you just need to know that it's there and it's going to do its thing. That's the tool we're using to turn all of our text into numbers that mean something to the AI. We're going to use our client, and you'll notice we're using our Supabase admin client here, right? We're not using the user version. We're using the admin version of this because we're accessing this chat memory table, which we haven't talked about this yet. We probably won't get into this, other than this is where we're storing all of our vectors, and the RLS policies restrict anybody. So nobody can access this. And that's why we need to use the admin client for that. And then we have a database query for match memory. So this is the Supabase function for how it reads the vectors. Again, we won't go into that. If you're interested, the Supabase docs describe that really well. So we'll link to those. And then you could also, again, take a look at this GitHub to kind of see exactly how we've tweaked that and implemented it for our application. Once we set up our vector store, right, where all of the vector information comes from and gets saved to, we create this vector store retriever memory. This is, again, another LangChain class that is how does it operate as a memory for the bot and for the AI. We tell it how many data points we want to return. So you can, again, tweak this. I liked 5 points. I don't have a big sample size as to the impact this might have in terms of cost and message size, but it was working well enough for me, so I kept it at that. And then our memory key. And then we create our combined memory with these two. And again, you'll notice we don't have our summary yet, and that's because we're doing something a little different with that. But we have our buffer memory, that's our immediate context and our in-depth context. And then we create our prompt. So this is our prompt, super basic, nothing too crazy going on here. The main parts of this is our summary of the conversation. So you'll see we actually save our memory summary on our chat object. This is part of our chat table. When we initially created the chat table, there was no such thing. If we open this up and go back over to Supabase, you'll see we actually have a migration here for chat memory and how that works. And you'll see we added a column for memory summary to our chat table. So that's where we're storing that information. So we have our memory summary, and then we also provide it with relevant pieces of previous conversation. And that's our vector memory. You'll see vector memory is a key here that lines up with the memory key. Our recent messages, which again, recent messages has a key that lines up with our buffer memory key. Here is our new user input, and our input is our prompt input template variable. And then we expect the AI to respond. We create a prompt template off of that. We say, here's the variables that we're going to go into that. Here's the template. We'll just talk about the streaming response. We won't worry about, the single response objects variation. All of these, a lot of this is copy pasted from LangChain docs. So there's not a lot you need to really know to get to use this. All this is doing is setting up that streaming behavior so that you are actually getting that real-time stream back to your client. We're going to create a chat OpenAI. So there's OpenAI and there's chat OpenAI. So depending on the different models you're using from OpenAI, we want to use the ChatGPT variation. So we're using chat OpenAI. Our model name, which we assigned earlier on in this application, whether we're using 3.5 or 4. We talk about it, are we using streaming or not? And then we have our callback manager. So these are really the three functions you're going to use, and they get called anytime something happens. So whenever the AI responds with a piece of text, right? This is our new token, right? If you're familiar with OpenAI, everything is grouped in tokens. It doesn't necessarily mean word, it doesn't necessarily mean letter. It's just a variable amount of data. So anytime there is new data, we are writing this back to the stream with all of the data. We're also keeping track of this we have this full text variable so that we know what the final version is at the very end. In case there are any errors, right, we're just aborting the stream. That will abort on the client, and the client will handle that. And then lastly, we have handle LLM end. So when it's finally done with its response, we're going to go ahead and close the writer, which will tell the UI that it's done. And then we're going to use our Supabase admin to write to the chat message collection, and we're going to insert that full text created by AI. And you'll notice we're using the admin client here again, and that's because we're bypassing rules, right? There was a specific RLS rule we added where you could only write to that if you're a human, right? So if we use normal Supabase, this will not work because it will violate that human requirement that you have to be to use. So that's why we're using our admin to bypass that and create the AI message here on our server. And then lastly, we have our summary. So we kind of glossed over this at the beginning of where that summary came from. We have a method here that actually is keeping a running summary of the conversation as it's happening. So we have this method, and it takes in the existing summary, the user input, and the output from the AI. And when we jump to that function, you'll see we're actually prompting back to ChatGPT again. And we have this template. Again, you can kind of come in and read this in the GitHub. But the TLDR is, take the current summary, here's the new lines of conversation, and here is the new summary that you should output. And so we give it that example so it knows how to respond, and then we actually give it the data. So the current summary, which is our input, which is our existing summary from our database. We pass in the new lines of conversation, the new human message, how the AI responded, and then we expect it to give us a summary. And then we're just going to pass that to ChatGPT. We're just using 3.5. We don't need version 4 for this. We want something quick and cheap. And then when we call that, we're not doing any data streaming here, nothing crazy and complex. We just wait for the response, and then we send the text back. When we get that text back, that's our new summary. And so we're just going to go update our chat. And we're going to go ahead and update that memory summary. And again, I'm going to point back to our RLS rules, right? We explicitly did not enable updating for the users because we don't want them to come in and mess with this memory summary. So we're using our admin so that we can bypass that rule so that the server can update our memory summary safely. And with that, that's everything that's going on here, right? So if you scroll down a little bit more, this is the exact same behaviors. This is just for the bulk response, right? Where it gathers the entire message and sends the response back in one go. And then if anything goes wrong, we just throw a generic 500 error with the message being like, I don't know, something blew up somewhere we weren't prepared for. and that's it, right? So it feels complex to kind of wrap your head around it, but then if you break it down piece by piece, there's really not a lot going on, right?
Yeah.
We validate our input, we configure our memory. How does the bot remember things? And then we ask it a response and we send it back to the client.
Well, there you go. That's awesome. That's pretty straightforward.
It's really great, honestly.
Yeah.
This has been a really fun project to build. And here's the great part about this, right? So this is all open source. If you want to just build and run this yourself, you absolutely can. Here's all you got to do, right? You're going to come back over to this. You're going to clone this repo. You go over to Supabase, right? You go to Supabase, spin up a free project, right? This is all running off of a free project. So go spin up one yourself, call it whatever you want. Grab the information you need and create this env.local file, or take the env.prod. This is mine, right? You can try to connect to it and hit the auth endpoint a million times if you want. But come in and drop in your configuration. What is your Supabase URL? What is your anonymous key? Okay. That's all you got to do to connect to your own Supabase. The migrations are already here. So you can use Supabase to link your database and then push all of these migrations up to yours. Or you could just open them, copy paste into your remote instance. Right? All of these will work. That will bring your database to where it needs to be. And then the last thing you need to do is create a .env file here in your Supabase folder, right? This is for our functions. And by default, all of the functions, they already have access to your Supabase instance because Supabase manages all of that. So you'll come in and you'll create your OpenAI key and you'll drop in yours. This is mine. It's going to be dead by the time you can try to use it, but it'll be gone. Don't worry. But you create this .env local file, right? And that's literally all you need to do. And you can spin this up and run it yourself and, talk to ChatGPT day in and day out as much as you want. That's the steps to clone this and build it yourself. So it's set up so that it can be super easy to do, really, really straightforward so that anybody can take this for a spin and play with it and do what you want with it.
That's awesome, Dallas. Thank you so much for showing us this. Where else can we find your work? Where can we go? Where can we find you and what you're currently working on?
Yeah, so I don't do a lot of building these days, so this was actually pretty fun for me. So that we kind of mentioned at the beginning, so I'm the product manager for Capacitor. So my job is just to try to understand how people use Capacitor and try to make sure that it does all the things that people want and expect it to do. So if you have any questions, I hang out in Discord a lot. So we have our Ionic Discord, which will be linked somewhere, right? Up there or over there. I don't know where things get linked. Come hang out in Discord and you can just feel free to ping me. I hang out in all the Capacitor channels and try to answer questions whenever I'm over there and help people out. I like to ask questions for feedback over there. So if you're wanting in, you want to share some feedback, that's the place to do it. Come hang out with me in Discord and we'll chat. You could try to talk to me on Twitter or X or whatever. I do stalk over there a little bit, but Discord's way more fun these days.
Yeah, Discord is where it's at.
It really is. So come hang out with me over on Discord and I'm happy to help with any questions, or if you have any questions about this project specifically, right? Hit me up. I'm happy to talk about any of the tech used in it. If you want to just talk philosophy or if you have specific questions, let me know. I'm always happy to sit down and chat with you.
That's awesome. Thank you so much, Dallas. And again, my name is Logan Braid, developer advocate here at Ionic. If you like what you see, please like and subscribe to the YouTube channel. And we hope to see you guys soon. Thank you so much. We'll see you later.
Take care.